we have the topic of volcanism. So in the volcanism, it includes all the processes. Volcanism here is going to include all the processes from the generation of the magma. First, there is going to be the generation of the magma. Then we'll be having the intrusion of the magma. First, the magma is generated over here and it is going to move, and extrusion of the magma is when the magma comes out is what we have, the extrusion of the magma. Intrusion of the magma and then extrusion of the magma. The magma is generated in the mantle. The mantle layer, asthenosphere, upper part of the upper mantle, then we have the asthenosphere. So we'll be having the upper mantle, then we have the asthenosphere. So the magma is generated in the mantle, then rise to the upper layer and it gets concentrated in the lithosphere. When it is concentrated in the lithosphere, 100 kilometers, it is intrusion of the magma, concentration in the lithosphere. Its concentration in the lithosphere. So we have its concentration in the lithosphere is what we be having the intrusion. Concentration in the lithosphere is intrusion. It's concentration on the surface of the earth. When it comes out, it is called as the extrusion. So when it comes out, this is what we call it as the extrusion. What causes the generation of the magma? When the melting of the rock is decreased due to the melting of the rock. How the magma is generated? The melting point of the rock is having a melting point of 100 degrees Celsius, right? So the temperature but here is going to be the 80 degrees Celsius. Why this rock is having like 100 degrees Celsius? Because the rock's melting point is dependent on temperature and the pressure. When the temperature is same over here, but why do the rock suddenly they melt? Because of the changes in the pressure decreases. The temperature is going to be same, but the pressure decreases, the melting point drops. Therefore, in some location in the mantle alone, we have the melting of the magma, and when the magma is melted, it is undergoing intrusion or extrusion. So it is undergoing the intrusion, or we can say it will undergo the extrusion. Now, temperature is same, the pressure is going to decreases, therefore the melting point drops in some locations in the mantle. This is only in some locations. So this is only in the some locations in the mantle. Now the pressure is going to decreases, therefore we'll be having the more heat generation. There is going to be more heat generation due to radioactivity. What if the temperature is in itself is increased? This is due to the radioactivity. Therefore, we say that there is more heat generation due to the radioactivity. Water content is increased at a particular portion. Therefore, the melting point is dropped. It is because when the water content is increased in the rock, the temperature of the rock will be decreased. Therefore, the outer temperature is increasing. And compared to the rock's melting point, the melting point of the rock decreases. If the water content increased at a particular portion, the melting point is dropped for the rock. Now, what causes the generation of the magma? First, where does the magma gets generated? The magma gets generated in the mantle. And what are the types of generation we have? Intrusion and then extrusion. Intrusion is when the magma is generated and it gets deposited in the lithosphere within the surface of the earth, and when it comes out on the earth's surface. When it comes on the earth's surface, we call it as the extrusion. When the melting point of the rock is decreased due to the temperature is same but the pressure is going to decreases, therefore the melting point drops, pressure decreases, but more heat is generated due to the heat generation is due to the radioactivity. Then the water content in itself is increased, therefore the melting point of the rock decreases. What is called as volcanism? Volcanism is going to include all the phenomena which is associated with the movement of the molten material from the interior of the earth to the surface. The molten material comes from the interior of the earth to the surface of the earth. What comes, the molten material comes out, is what we call it as the volcanism. It involves three main processes. First, the magma is generated because the rocks are melting. When does the magma is generated? The rocks are melted. It is when the magma is generated. And the next step is intrusion of the magma and extrusion of the magma. Extrusion of the magma. When it is extruded, when it is inside, it is called as magma. When it comes out, it is called as the lava. The first thing is the generation of the magma. When happens in the interior of the earth, this one is going to happens in the interior of the earth, the lower or the upper mantle. So we be having the mantle, right? The lower or we be having the upper mantle is present over here. That is the asthenosphere. Due to the increase in the heat is going to increase or the decrease in the pressure or increase in the water content, which is lowering the melting point of the rock. Intrusion of the magma in the lithospheric layers and extrusion of the magma to the molten material to the surface. Now, what is a magma? Mixture of the solid, liquid, and then the gas is what we say it as magma. It is going to have all the three forms. The magma is going to have the solid, magma is going to have the liquid, and then the magma is going to have the gas. So it is a mixture of the solid, liquid, and then we have the gas. It is a molten silicate. Silicate, it is in the form of a molten silicate, right? What is a magma? Magma is a mixture of everything. That is the solid. Magma is a mixture of the solid, magma is a mixture of liquid and gas. So magma is going to consist of the solid, liquid, and then we be having the gas. Magma consists of the solid, liquid, and then we have the gas. So the molten silicate, it is the molten silicate. Above the surface is what we call the lava. What is magma versus lava? Magma is a hot molten silicate material, a combination of solid, liquid, and gases. We tell magma is a hot and then it is going to be molten silicate material. Molten silicate material, which is going to comprise of the solid, liquid, and then the gas. Solid, liquid, and then we have gas. When this magma reaches the surface, it erupts as lava. Lava is more volatile than magma and it cools either on the surface or underwater. The cooling of the lava is either under the water or on the surface. Now magma lies below the earth's crust surface. Lava comes above the surface. The temperature of the magma is lower. The temperature of the lava is higher. When it is having lesser temperature, it gets accumulated over here. When the temperature rises, it gets extruded out in the form of lava. Therefore, the temperature of the magma is comparatively lesser than the temperature of the lava. Fluidity of the magma is lower. It tends to move slow, and the fluidity of the lava is more. Result is in the formation of plutonic rocks or intrusive igneous rocks, and volcanic rocks or extrusive igneous rocks. So we have two types of the rocks. The first one is going to be the plutonic rocks. Plutonic rocks are going to be the intrusive. Plutonic is intrusive, which is inside. Intrusive, and they are igneous rocks. So intrusive igneous rocks, and then we have the volcanic rocks or extrusive igneous rocks. Example is granite, and basalt is a extrusive igneous rock which is present on the ocean floor, right? So here when we are looking on to the difference between the magma and then lava, once we have that, we know that it is below the surface and it is above the surface. This temperature must be low and this temperature must be high for it to come out. Magma to come out, it must increase its temperature. Then the fluidity also lower, and fluidity also is higher. Viscosity, you can say viscosity is high and then it is viscosity is low. Temperature, fluidity, and results in the formation of plutonic rocks and volcanic rocks. Plutonic rocks are nothing but the intrusive igneous rocks, and volcanic rocks are nothing but the extrusive igneous rocks. Now, what is the type of the magma? The types of the magma is granitic. See, this is having granite. Basalt is having less silica content. We have, this is a felsic igneous rock. When the silica content is greater than 66%, when it is lesser than 52%, it is called as mafic or basaltic igneous rock. The silica content is less than 52. Now over here, what are the types of the magma? We are calling it as a granitic magma and basaltic magma. Example itself, we are mentioning the granite and then we have the basalt. So granitic and then we have the basaltic. Very difficult to generate. They are intrusive igneous rocks from the magma. Aluminium content is high in the continent because melting of the continent is difficult, right? Oceans get melted frequently. We have the C4 spreading theory by Harry Hess, where the oceans are continuously melting, therefore the oceanic rocks are not greater than 150 million years. We do not see continental crust melting. We do not see the continental crust melting. Therefore, we have granitic magma, very difficult to generate. Example, they are present as intrusive rocks, that is from the form of magma inside the volcanoes, and they are not present outside the surface because the continental crust melting is very difficult. Here, inside the rock, inside the volcanoes, they are present in the form of intrusive igneous rocks. This is the type of the magma called as the granitic magma. Now, the silica content is 60 to 70%, that is, it is having greater than 50%. Light in color and it is lighter in the density. Everything is light, and then the basaltic magma is dark in color and it is more fluid. We know that basaltic is more fluid because it is extrusive, which is more fluid. It is going to consist of the magnesium and iron. More of magnesium and then we will be having the iron. Now it is also low temperature. All the features of the intrusive rocks is going to come here, and silica and aluminium is more. This results into the continental crust. So we say that the granitic magma results in the continental crust, whereas we say that the basaltic magma, it results into the formation of the oceanic crust. Silica content is less because Cl. The silica content also is less. Magnesium content is more and the iron content is more. It is towards the knife. That is, it is almost having the similar features of the mantle. High temperature. This is going to have high temperature, more fluid. All the conditions for basaltic magma is going to have all the conditions of the lava. All the conditions of the lava. It is an extrusive rock. The silica content over here is less. Lava which is formed on the oceanic floor. Therefore, the silica content is less. It is dark in color. It is more fluid and it is having high temperature. Magnesium ion is more. Now, what is plate tectonic theory and magma generation? In the plate tectonic theory, we will be saying the convergent plates, divergent plates, right? When in the divergent plate boundary, we are having the divergent plate boundary, right? When we go back to the plate boundaries, here we have the plate tectonic theories, and then these are the plate boundaries. When ocean and ocean are converging, for convergence we have ocean and ocean are converging, continent and sorry, first we are seeing the divergent. When ocean and ocean are diverging, again here due to the lava we again see that the crust formation, that is how C4 spreading theory is there. The rocks over here on both the sides are of less age compared to the rocks. These are older rocks. The rocks near the ridge are of lesser age compared to the rocks which are far away and they are older age. Now, when we are seeing about the divergent, here we are seeing the ocean divergent. Ocean floor is basalt, right? So, it is going to result in the basaltic magma. Basaltic magma is the one which comes out of the ridges. Now, continent divergent. When a continent and a continent is diverging, what kind of a lava comes out? Even the basaltic magma only comes out, right? So convergence, when ocean is converging, it is basaltic. When ocean and continent is converging, the it is again basaltic, because the oceanic plate is denser and it is the one which is going to go down. The continental plate floats, the oceanic plate goes down, and then it again comes up in the form of volcano. Therefore we have the basaltic magma again over here. We say when the continent is converging. For the continent convergence, we can have there is no magma in the continent convergence, because continents are very resistant to, and they are very thick to go and form the magma. They do not go such deep because the oceanic crust or the mantle is very denser. The continental plates are very lighter, so they do not lead mostly to the formation of a magma. When ocean and ocean are diverging, basaltic magma is formed over here. This magma is generated along the mid-oceanic ridge. So when the ocean and the ocean are diverging, we have the basaltic magma. The magma is generated along the mid-oceanic ridge. It is leading to the extrusion. It is leading to the extrusion of magma. It is leading to the extrusion of the magma at the oceans. The source is a convection currents or the mantle plume. Quiet and continuous volcanic eruptions, because it is going to be continuous in the mid-oceanic ridges. Therefore, the source is going to be the source is the convection currents, and then we have the mantle blooms. Quiet and continuous volcanic eruption along the fissures. Along the fissures, the plate boundaries are moving, and therefore we have no pressure laid on the crust. Magma is not blocked by the crust. The plate is moving apart and allowing for the magma to rise. Continent are diverging. It is also results in the formation of the rift valley. When ocean are diverging, it is mid-oceanic ridge when the ocean, rift when the continents are rift valley. It is again a valley, right? Rift valley when the continents are diverging. We have the rift valley. Basaltic magma comes out. The source is convection currents, and a mantle plume causes rift along the continental crust. The magma comes from the mantle and it is basaltic. The magma is basaltic. In nature, Therefore, it leads to the creation of the oceanic crust again. Initially explosive, later it is quiet when magma starts to erupt between the continent crust. Convergence plate boundaries. Ocean convergence, ocean continent convergence. Magma is not the one which is coming from the interior. It is because of the subsiding plate it goes and it melts and it comes out, rises as magma and causes volcanic eruption. This magma is andesitic magma, is neither, we say andesitic magma is neither basaltic nor it is granitic, a mix of both, right? We have the andesitic magma. Andesitic magma is a mix of both granitic and basaltic. The major portion of the ocean crust, but very significant amount of the continental crust, is deposited on the oceanic crust. Therefore, it is intermediate because due to the erosion of the continents, the continental crust get eroded and it is also deposited in the oceanic crust. That is why we have the mix andesitic magma. Now the formation of the island arcs. We are forming the island arcs and then we have the volcanoes andesitic in nature. Example, the Andes mountain in itself. Now nature is explosive because accumulation pressure explodes. When it is subducting, we have pressure and it needs to come out, it needs to melt and come out, right? Therefore it is accumulation and the pressure explodes. Andes, Pacific Ocean, Japan, Indonesia. Now what are hotspots? Hotspots are locations where isolated mantle plumes are there in the intraplate itself, within the plate itself, right? So a plate is there, but suddenly we have volcanoes. Usually, volcanic activities are found only on the plate boundaries. Volcanic activities are found only on the plate boundaries, but we have the intraplate. Intraplate, when we are having it as a intraplate, is what we have the local locations where isolated mantle plumes are there. So local locations, we have them as a local locations and isolated mantle plumes are there. We'll be having the isolated mantle plumes are present over here. It results in the eruption of the basaltic magma is getting erupted. So what is getting erupted? The basaltic magma is getting erupted over here. The basaltic magma is getting erupted over here due to the origin in the mantle plumes Here it is a basaltic magma because the mantle plumes are originating in the intraplate. Reunion hotspot and Hawaiian hotspot. The Indian plate was passing over this Reunion hotspot, which is located in the near the Madagascar. So Reunion hotspot is located near the Madagascar. When Indian plate passed through this Reunion hotspot, the basaltic magma eruption led to the formation of the Deccan Plateau or Deccan Traps. The nature of the basaltic magma is that it flows; it do not accumulate it is just flowing. It is fluidity is high, therefore it flows, it does not get accumulated, therefore it flowed in the entire plain region. We will be having the Deccan Plateau, right? Example is Deccan Plateau. This is when the Indian plate was passing over the Reunion hotspot, basaltic magma eruption, Deccan Plateau, Deccan Traps. The nature of the basaltic magma, it flows and it does not accumulate, flowing in the entire plain region. Now what is the distribution of the volcanoes? We have the ridge volcanism is in the mid-oceanic ridges. Rift is when the plates ocean divergence, continent divergence is when we have the ridge. Rift is continent divergence is when we be having the rift, and then we have the ridge. The ridge is going to be the ocean divergence is where we be having the ridge. Ridge volcanism. The volcanoes are located along the mid-oceanic ridges. Continuous chain. They are of the continuous chain. These volcanic eruptions, example is the Mid-Atlantic Ridge and Carlsberg Ridge. Carlsberg Ridge is in the Indian Ocean. So usually we will be seeing the mid-Atlantic ridge as an example, but here we have the Carlsberg Ridge. Carlsberg Ridge is in the Indian Ocean. Example is the Carlsberg Ridge, which is in the Indian Ocean. The oceanic floor occurs through the mid-oceanic ridges. Every ocean will have a ridge, even the Pacific Ocean. Southern part, there is a ridge. Eastern Pacific Ridge. Rise is same as a ridge, but it is less lower. So every ocean, the Pacific Ocean, we call it as the Eastern Pacific Rise because it is same as a ridge, but it is little lower than the ridge. In the Indian Ocean, we have a ridge, and then the ridge is called as the ridge in the Indian Ocean is the Carlsberg Ridge. Volcanic activity is non-explosive and then continuous and fluid type. Volcanic arc. The arc is the island arc subducting of the ocean. Example is when the ocean and the oceanic plate are subducting, it results in the formation of the volcanoes. Since the plates are moving, it forms volcanic arc. Japan, Korean, Philippines, Indonesia, Aleutian. Right. Example is Japan, Philippines. Volcanic chains. Chain is when ocean continent collision. When ocean collision is going to cause the volcanic arc. We know what is mid-oceanic ridge, and next term is volcanic arc is because of the ocean collision. Ocean continent collision is going to create a formation of the volcanic chains. Nazca plate is colliding with the South American plate. These are the straight line of the volcanoes along with the continental margins due to ocean continent convergence. Nazca plate, when it is colliding with the Nazca plate is there, and then South American plate is there. When these two plates are colliding, Nazca plate is a oceanic plate and South American plate is a continental plate. We have all volcanic chain. This is a straight line of the volcano along the continent's margin. Along the continent's margin due to the ocean continent convergence. Example is the Andes and the Rockies along the fold mountains. Volcanic clusters we have along the rift valleys when the continent are diverging. Continent we have volcanic clusters over there. So when the continents are diverging, we will be having the volcanic clusters. Ocean are diverging the line of volcanoes, ridge volcanoes, right? Whereas continent are diverging, we have volcanic clusters, example East African valleys. So we have the volcanic arc, volcanic chain, rift. In the rift mid-oceanic, sorry, we have the volcanic clusters, mid-oceanic ridges. This is along a ridge. This ridge is because of ocean divergence. Volcanic arc is when ocean convergence. Volcanic chain is when ocean continent converges. Volcanic chain. Volcanic cluster is the rift. When continent diverges. When ocean diverges, we have the mid-oceanic ridge. Volcanic lines are along the hotspots. We be having the volcanic line. The hotspots are nothing due to the mantle plumes. Due to the presence of the hotspots, and they are moving a oceanic crust. The oceanic crust is moving. The hotspot is not active, but the hotspot is active, but the volcanoes are not active. Therefore, they are moved away from the volcano. Is what we have the volcanic lines. What is the features of the volcanoes? Extrusive features is due to the eruption of the magma outside, we'll be having a cone which is forming outside, right? Volcanic cone, the cone which is formed due to continuous eruption. Volcanic cone, this is because of the eruption, and the eruption gets accumulated over time. Volcanic cone. What are the extrusive features? So these are like volcanic features. Extrusive features, and then the extrusive features are a cone which is formed over here, and a volcanic cone. Types of the cone: shield, ash, cinder, strato. Then a crater is being formed, caldera, if it is very wide crater. Flood basalt province. Basalt, it just flows. The basalt flows, the basalt does not accumulate. So we have the flood basalt province. Hot spring is again an extrusive feature. Geyser, fumaroles. Intrusive features is batholith, lopolith, laccolith, colith, sill, and then we have the dike. These are the extrusive and intrusive features of the volcanoes.